This is chapter 11, problem number 32. This problem asks us to find the final angular velocity after the student pulls the two dumbbells inside, closer to the center of, or the rotational axis. This is a conservation of momentum problem, and so the initial momentum is equal to the final momentum. In both cases, we can use the inertia times omega and so if we solve for the final velocity, okay, and so first we know that the initial inertia is equal to the rotational inertia of the student plus the stool, which they give us, and is 3 kilograms meters squared, plus the rotational inertia of the two point masses, and so that would be mr squared, and there's two of them, so it's 2 the initial angular velocity they also give us, and it's 0.75 radians per second. And the final inertia is equal to, once again, the rotational inertia of the stool plus the 2 point masses, but this time the radius is 0.3 meters instead of 1 meter. Now we plug this back into this equation, and we get .91 radians per second. For part B, they asked us to find the initial and final kinetic energies. So the initial kinetic energy is equal to 1/2 I omega squared. We know from here the initial inertia and the initial angular velocity, and we get 2.53 joules. For the final kinetic energy, it's the same equation, but this time using the angular velocity we found here. And we get 6.4